Right. Good morning, my dear students. Uh, Welcome to this session on Unit 2 of your syllabus, Structural Analysis to uh, the laterally loaded building frames analysis by approximate methods. So we are discussing about the approximate methods. One of the methods that we have taken up for discussion is portal frame method. So portal frame method has got two assumptions which we have discussed in the earlier sessions. And now we have taken up a problem also, an example problem. We have seen the step-by-step procedure, uh, how we solve the internal uh, force quantities, the five quantities, three in column and two in beam. Okay, sessions started calculating uh, uh, like column shear we have started with. So all column calculated, and then we have calculated column end moments. So now in this session we will discuss in detail how we calculate the next quantity, the connecting quantity, after knowing column end moments, and you are able to calculate beam end moments with what you see it here is uh, joint moment so moment equilibrium of a joint. So the joints present in the frame you have to consider, and then you know the column end moments. So at a joint where both beam and column come and join, so you know the end moment of a column, and you are now required to calculate beam end moments. Okay, so let's see anyhow in detail. So I have taken a joint A. So I have applied the equation sum of all moments at joint A is equal to 0. Okay, so let's see what are all members joining at A. Okay, so this previous answer that you have, step 2 solution. So joint A, if you see, so there is beam AB joining here and column AH joining at A. Okay, my equation will be MAB is equal to 0. Right, so MAB plus MAH is equal to 0. So I have selected a joint where there are two members joining. One is a column, another one is a beam. So we know the moment of a column at A. So that is 20. So that is taken here. If you want, you can see in this. So 20 kilonewton meter is column end moment. Okay, right, 20 is substituted. So what do you want now? Beam end moment. So end A of a beam AB, what is a moment? It is minus 20. So in the sense, it is opposite to this direction of moment. So what is the direction of moment in AH? It is clockwise. So opposite means what? It's anti-clockwise. The same value, 20. Okay. So this is what is moment in AB beam at A. Okay. So let's have like that. So this is how we solve in a simple way how we solve for beam end moments once you know column end moments. So likewise we need to take all the joints and you have to calculate all beam end moments. So at A the moment is 20, and so this is AB. Okay, so where you have anti-clockwise moment of 20. Okay, so as there is no gravity load acting on this. Okay, so beam other end of the beam will have no change in bending moment. So the other end also should have same bending moment. This is what okay. So this is A. So MBA should also be same. Okay, in moment. So 20 anti-clockwise 20 is the moment acting from A to B, no change. Okay. What is the reason? Because uh, no load acting on AB. So if you have some load acting on AB, then the moment will change. So no loads, no gravity loads are acting at on AB. Hence, so moment at A, whatever is the location, same moment you can carry out even with the moment center change. Okay, so that is what is the reason why it is written for B also has got same value and same nature. Okay, so next let's go to joint B. Okay, so let's see in the diagram what is there. So B is a joint, now it is taken. So you have three members joining there. There are two beams and one column. So column moment is already known, which is BG is the column, BA beam, and BC is another beam. So you write the equation first. MBA plus MBC and MBG is equal to 0. MBA is calculated, substitute it here. MBG, you know it earlier from the previous step 2, so substitute there. So MBC value is minus 20. And you know the end B, if you have some value, end C also will be same. So 20 will remain as it is. Okay, so even for this also you have minus 20, minus in the sense anti-clockwise. Okay, so this end B and end C both are 20. So no change. AB and BC, both the beams has got same value and same nature. So next go to the another joint D. Okay, so instead of going to joint C, you can go to joint D. So reason is simple. Joint C, if you go, you have three members. Joint D, you go only two members. What you want is only just beam CD value. Either you take joint C or joint D, you get the solution. Okay, so either you know moment at D, it will be same at C also. Okay, so that's why instead of going for C, we have gone for D, right? Okay, so let's see the equation. So DC MDC plus MDE is equal to 0. So DC is beam, DE is column. Okay, so you know DE value 20. Substitute in this equation, you get DC value. So 20 is substituted. So DC is minus 20, same as C also. So that is written here. So moment at D is equal to moment at C. Okay. So this is how the top story beams bending moment, nothing but end moments are calculated. It's simple. You see, just take the joint and apply equilibrium of moments, and careful in signing the sign conventions. Then only your solution will be proper. Okay, so that's how the uh, top story beams are being solved. So you see, all the beams have got same moment and same nature. So 20 anti-clockwise is beam moment. Okay, all the beams, top story beams have got same bending moment and same nature. So let's work out the next story beam. Okay, so HG, beam HG, beam GF, and beam FE. Okay, so there are three beams. Let's calculate the right. So write equilibrium equation at the joint H. Okay, let's see joint H. So you have three members joining H, two columns. One is this one, and a beam. Okay, so HA, HI, HG, right? So always read the name of the member from the joint where you are applying the equation, right? So you are applying the equation for joint H. So read the member name from H, HA, HI, HG. Okay, so likewise. So now you apply the equation. HA is a column, HI another column, HG is a beam. So you want this value and you know these two values. Okay, so substitute them. 20 is the column end moment and 30 is the column end moment, the above that beam and below that beam. Okay, so now the beam end moment at H, location H, is minus 50, and other end also same, minus 50. Okay, so let's see. So here if you see, minus in the sense anti-clockwise, so 50 is the value, right? So here also it is 50. So drawing the moment is much important. How you draw is much important. So you see, the clockwise 30, clockwise 20. So total clockwise 50, balanced by anti-clockwise 50. So total moment is 0 at H. Sum of all moments at joint H is equal to 0 is satisfied. Same way, okay. So likewise, all the joints must satisfy the joint equilibrium. Now, you can even see the top story also, 20 and 20 clockwise, 20 anti-clockwise. Same here. So 40 clockwise column, 20 and 20 both anti-clockwise, 20 plus 20, 40 anti-clockwise beam moment, total is 0. So likewise, we have to evaluate all these. So going for joint G, so now you have to read the member name GH beam, GB column, GJ another column, GF is beam. So you need this value, GF value. You know all other three values. Say GB 40, GJ 60, and GH 50. And directions you must be careful. 60 clockwise, 40 clockwise, whereas 50 is anti-clockwise. Okay, so that you should be careful with this equation. So you see, sigma mg is 0. So GB is a column, 40 plus 40. So all clockwise I am writing it as 40. GJ column below, 60. So GH is a beam, minus 50. GF we want the value. Okay, right? So 60 plus 40, 100 minus 50 is 50. When it goes to the right hand side, minus 50. So location G in member GF, bending moment is minus 50. So even at F it is same, right? So that's how it is. So GF or location G or location F, both are 50. Okay. So right, if you see the top story beam has got 20 bending moment common. Same here, it is going to be 50. So even now you can just a guess without even calculating. You can just put 50. Okay, but anyhow, you should go by the procedure. So 30 clockwise, 20 clockwise should be equated by 50 anti-clockwise, even at E also. So next joint that we are going to take is not F, it is E. For simplicity, you have 3 members there, whereas F has got 4 members. Okay, so instead you can go for joint E, right? So that's how the second uh, story beam is being evaluated. So first story beam is left over. Similar way, okay. So if you go by procedure, and joint E I have taken. So ED is a column, EL is another column, EF is a beam that you want. So minus 50. So it's just a repetitive one. Right, going for the first floor beam. Okay, so joint L equilibrium equation. Okay, let's see. Joint L. Okay, so we have taken the rightmost joint. Okay, so LM, LE are columns, LK is a beam. Okay, so 30 clockwise, 40 clockwise, total 70 clockwise should be balanced by 70 anti-clockwise bending moment. That is what is MLK. Let's see by the equation. It's like that, just simple. So LE, but LE, LM, LK. So 30 plus 40, 2 columns. Okay, LM, LE column above that beam, LM column below that, LK is a beam. Okay, KL if you come from left. So minus 70 is the value. Okay, so even at L, joint L, or the other end K also, both are same, 70. So 70 is going to be the bending moment. Even if you take the other joints, and you can prove that the total beam will have 70 value. Okay. Or otherwise by just the balancing concept, you can put the value. So 70 here. Okay, so 80 plus 60, 140, minus 70 will have minus 70. Well, so total 140 there, column moment, and 140 beam moment should be there. Same way, okay? Same here, 70 and 70. Okay. Right, similarly, the other end also will have 70 there, and 40 plus 30, 70 will match with this. So simple to brief, topmost beam will have 20 bending moment anti-clockwise. Next story below that will have 50 kilonewton meter anti-clockwise bending moment. Below that, the first story beam 70 anti-clockwise. So all column end moments are clockwise, all beam end moments are anti-clockwise. Okay, so they are just uniform in nature. Okay, so top story beam has got less bending moment. When you go down, beam bending moment is increased. Okay, right, that is drawn in this diagram. Okay, whatever we have just calculated, whatever I have drawn while explaining, everything has come into diagram now. As that's what I said. So you have got some diagram drawn initially. Once you answer that the sheet, so once you half of the sheet you draw a big sketch of the frame I said for posting all the answers. So step 1 answer, column shear you draw first, then step 2 column end moment you have drawn. Now you draw this green arrows, all these green colored arrows, are beam end moments that you draw like this. You see how you have to accommodate all the arrows. Okay, there should not be any confusion. Okay, so you may use different colors for draw, or else just uh, maybe with simple pen and pencil or whatever it is. But there should not be any clumsy in noting the value or no giving the notations. There should not be any deviation and any confusion. And like, so it should be very clear in picture. You see this picture, it is very clear what is a beam end moment, what is a column end moment, all that. Okay, so this is how simple it is. Just by the joint equilibrium, uh, you can easily evaluate step 3 beam end moments. Okay, right, thank you.